Hi, so this is the second part of the kata. I'll be trying to split this into two videos. The first one would be the first two bullets, and the second one would be just this one. This kata deals with interaction-based tests, so I would recommend reading up on the dependency inversion principle. Just to give a small summary, imagine a copy program that reads up of the keyboard and writes to a printer. So now it has a dependency on the keyboard and the printer. The principle recommends creating abstractions called a reader and a writer so that the dependencies are inverted and the copy program no longer depends on the actual keyboard or the actual printer. The only changes that can ripple through to the copy is when the abstractions change. So changes in the keyboard now do not affect the copy program. That's the idea in brief. From the unit testing point of view, it also allows us to slot in a fake reader and a fake writer, so I don't need the keyboard and the printer to test the copy program. Alright, so let's just take a look at the code that we have. So we have a single test fixture with about 10-13 tests, and all the implementation is in the form of private methods in the same class. So if I bring up the class diagram view, I can see that I just have one single class. There is no web of objects yet. Okay, so let's begin with the kata. So the first thing that we want to do is that when I call add with some input, it should also output the result to the console. And we need to do this test first. So the fix appears to be simple. We just need to extract this as a variable, print it, and then return the variable. But how do I test this? So that's our challenge for now. So before we begin, let's just run all our tests again to see that we are starting with a clean slate. Okay, so all the tests run. I am going to set up beacons again, and this time I am going to I don't have it copied yet, so I just need to copy the command line. So everything starting from this quote here to the end of the line, I just paste it here like this, and I choose I want the console runner. So now when I rebuild my solution or the projects, if the build succeeds, the tests are run automatically and the results are published in the ID here. Alright, so that's hooked up, so we are ready to go. Rather, this should be message shown on display equal to 9. Typos. Okay, which means I need a property. Can be a factor equal to 9, and that should happen when I call 135 add 135. We need to pass in a display, or rather we should so in order to pick the console, I don't want to use the real console in my unit test because it is difficult to sense or control. For example, I can't easily fetch what is being shown on the console, so I need to create an abstraction according to the dependency inversion principle. same abstraction is called display, and then I can pass in a fake display like this, and I would pass in the object as a method parameter to add, and then add code invoke display.show to print the result. Let's create an interface or abstraction or a role. The console is just an implementation of this role, so it is a type of display. But okay, problem is that requirement doesn't show that we are allowed to change the add signature. Instead of method parameter, it would have to be a constructor parameter. Another way to do this would be doing this. So the calculator can then cache the display object, and then when I call cal.add, it will use that display. So this is what we are going to do. Create a class, and as calculator, Resharper populates the constructor that we need. Make this internal. What that was, but okay. Right, and now we need to move the add method to the calculator. Here it is. I'll move it to, and it will need all the private methods in as well. So we do that, and now we get a add is private, so we'll make it internal so that calculator can access it. And we'll make it non-static. That does that, and we also use self-shut. So instead of creating a fake display class, we'll make the test picture behave like a fake display. Some compile errors as well. And in the fake implementation, I will just cache the value that is shown. That leaves the open line, so I'll create an object here because now add is an instance method, but it does not have a default constructor, and I do not want to pass in display for these tests, so I can create a overload to make the compiler go away. Build, and I have my first failure. Correct. To fix this, first I'll move this to a separate class. That goes find display and do the same. Okay, so here's where we have to make our changes. First thing we can do is cache the display as a member variable, and then add can type this as a variable, use display to show the result. That should pass. For the default constructor, you don't want a display, and I don't want to check for null, so I will use a null object pattern here, and return null object. A null object is a class that has no ops or does nothing when it is called. So this, I'll move this to the end of the class. And I will move the default constructor up. So static field up as well. So let us move. Build now. And the test passes. We can check for an opportunity to refactor. This looks clean enough. Let's go to the text class. Just highlight that this is build again. Okay. Just to check if, just to prove that it works, what we can do is, just for our confidence, we can print the value here. A real implementation would, instead of having caching the message, it would print the message to the console like this. Build again. Let's drop to our console and run our test again. And we should be able to see the number shown on the screen. There it is. So it works. Come back and build and false beacon. And we can move on to the next test. So the next requirement is that we should have a console app that the user can invoke like this. The input now is inputs, and it should print the result like this. Okay. So that means we need a console project, so I'll do that first. I'll add a console application. Application is correct. I'll here. This is what where we want the project to be created, and does it. It adds a program class by default. So in this class, what I want to do is I want to keep the console app thin. I'll probably delegate to a class like this. And now if I can develop the console class using TDD, I don't need the console app ever in my text. Let's do that. I'll just comment this for now and add a new text section. Again, this would be similar to this time the input is input, so like this, and we'll assert that put it inside here, get a property, time string, auto property, and make it private. Once again, we'll have to pick out the display, so this time we'll use parameter injection, and create the class. Finally, we need to first need our data field display. So I use selection again. And once again, I engage the value. This is identical to our previous test. We build it. We get our expected error. So now we can implement this line. We will trim the quotes. Capturing the value. Our result, and then we print it to the display. Should do it. And there we have it. So we have our console calc class created. Now the next thing that we need to do is to allow a program class to be able to call console calc, but I don't want my EXE project or the console app project to reference my test. So we now need to extract the production code into a class library. So we'll begin with console calc, and we'll create a class library project. Default class. We actually refactoring now, so we can move it to that pulls in display and calculator. So the calculator has no errors, display has no errors, console calc has no warning, which I can fix. Now that has not got any errors. Let's look at the test fixtures now. So the test assembly now needs to reference the class library. We use the classes, it's correct, and ditto for the other test fixture. Still has some errors now. So the first error is that calculator is not public, so it has to be. Second error is that should be public. We will do that, those changes, and now the test fixtures are okay. Finally, to the console app. Console app can also reference the DLL. We have an error here where we need the display. So now we need to pass in the real display. So let's create a class for that. I'll create a class, and here it will actually write to the console. So it's actually an adapter so that it conforms to the display abstraction. Okay, build. And succeed. Let's pause beacon for now and let's try it out. And we can move our our control app like this, and you can see that it's printing the results to the console. Let's try some different numbers, and it seems to work perfectly. I'll break the video and I'll see you on the other side of the break.